Assalamualaikum and good day, Doctor. My name is Nur Iqbal Hafizin bin Muhammad Zaidi and I'm from RK85. So this is my answer for assignment 2, question 5 for ENT 323 electrical machine and drives. The question asks to explain the application of power electronic device for renewable energy. Propose suitable electrical motors and drives that can be used for renewable energy. So we start with application of power electronic device for renewable energy. So the question that we can ask is, what is UPS? And also, what is PCS? I will explain to you. So firstly, we need to know what is renewable energy. So renewable energy source are energy source that are always being replenished and they can never be depleted. Some examples for renewable energy source are solar energy, wind energy, hydropower, geothermal energy, and biomass energy. We also can know renewable energy is something that can run out or is endless. So we move to power conditioning system, which is the stand for PCS. What is PCS? This is PCS. The power conditioning system refers to the general class of device that use power electronics technologies to convert electric power from one form to another. For example, converting between direct current DC and alternating current AC and providing specific operational interface functionalities required by the subsystems being interfaced by the PCS. Next, for in the solar energy facility system, the collection of electrical equipment that converts direct current DC from a photovoltaic array to alternating current AC or that conditions AC current produced at CSP facilities to match the voltage and phase condition of the bulk electricity grid to which the solar energy facility is connected. Besides that, power conditioning system also will include system monitoring device and isolation switches that can isolate the solar energy facility from the bulk electricity grid during of normal conditions that could jeopardize or damage either the facility or the grid. In addition, DC power is the electric power collected by solar panels and cannot be transmitted directly to typical residential homes. Therefore, DC power must be converted to AC power for general purpose use. PCS for photovoltaic generation can convert DC power to AC power, so we can use that. And PCS is said to operate more effectively as its conversion efficiency will be increased. So next, we move to uninterruptible power supply, which is the stand for UPS. This day, clean and feasibility vitality is included to the civilities, so a renewable energy integrated UPS system is displayed, which makes right the effectiveness, economy, and unwavering quality with multiple storage and hybrid energy resource. The distributive generation is in the same category as the UPS system, provides standby or backup power when main power source failure or interruption occur and is sometimes used during peak hours for load sharing. It also increases reliability and cost reduction. For the smart grid, an intelligent UPS system is proposed, in which is reliable, flexible, and energy saving for connecting with distributive generation source. Uninterruptible power supply (UPS) also based on compressed air energy storage system, which is CAES. The system is composite technology which consists of an energy storage system and electric power supply system. As we can see in the figure at the right of the slide, that is for CAES. The energy transferred from the renewable energy resource to the CAES system drives the air compressor engine to produce high pressure compressed air to be stored in a vessel. CIES is one of the commercial utility scale grid storage technologies whose aim is to store energy during periods of low energy demand and extract it for use later during periods of high energy demand. Furthermore, CIES technique involves storing a stream of air as compressed gas. To achieve this, ambient air is being pumped into big storage tanks or in caverns located underground or deep underwater. So we move to electrical motors and drives for renewable energy. So for power electronic device are used to convert electricity from one form to another. A common example of a power electronics device is an inverter, which converts direct current DC electricity generated by solar photovoltaic panels into alternating current AC electricity for use on the electrical grid. AC is the standard used by all commercial appliances, which is why many view inverters as the gateway between the photovoltaic PV system and the energy of taker. Inverter also provides a number of other capabilities and services to ensure that the inverter can operate at on optimal performance level, such as data monitoring, on advanced utility controls, on applications and system design engineering. At first, solar panels generate DC electricity which must be converted to alternating current AC electricity for use in our homes and business. This is the primary role of the solar inverter in a common string inverter system. The solar panels are linked together in series, and the DC electricity is brought to the solar inverter, which converts the DC power to AC power. In a microinverter system, each panel also has its own microinverter attached to the rear side of the panel. The panel still produces DC, but is converted to AC on the roof and is fed straight to the electrical switchboard. Microinverters also let each panel work independently and are well suited to complex roofs or locations with shading from trees or rooftop. So furthermore, as DC-DC boost converter is interfaced with proposed wind system to step up the initial generator voltage and maintain constant output voltage. The fluctuation nature of wind makes them unsuitable for standalone operation. As the figure, to overcome the drawbacks, an energy storage device is used in the purpose system to compensate the fluctuations and to maintain a smooth and continuous power flow in all operating modes to load. Side-directional DC-DC converter, which is standard for BDC, is also capable of transforming energy between two DC buses. It can operate as boost converter, which supplies energy to the load when the wind generator output power is greater than the required load power. As it also operates buck converter, which charges the battery from the DC bus when output power is less than the required load power. So this is for my presentation for question 5, and thank you. Assalamualaikum.